Lesson 12-7, Mixed Expressions and Complex Fractions. And in this lesson, you learn to simplify mixed expressions and complex fractions. Why is it important? Because you can use rational expressions to solve problems involving acoustics and statistics. And let's take a look at this real-world application in table tennis. So a table tennis ball weighs about 1/10 of an ounce. So how many table tennis balls would weigh 1 and 1/2 pounds all together? And we will solve this in example 2. So a number like 1 and 1/2 is a mixed number. Expressions like a plus b over c and 4 plus x over y all over x minus 5 are mixed expressions. Okay, changing mixed expressions to rational expressions is similar to changing a mixed number into a simple fraction. We call that improper fractions. So in this case, we learned this in 6th grade to be able to change a mixed number to an improper fraction. Let's say, for example, if you have 5 over 7, 5 and 4 sevenths. Okay, 5 and 4 sevenths is the same as 5 plus 4 sevenths. And when we change this into an improper fraction, we simply multiply 5 times 7, then add 4. So 5 times 7 plus 4 will give us 5 plus 4 over 7, or 39 over 7. So the improper fraction in 5 and 4 sevenths using this process is 39 over 7. And we will use the same process or the same steps to be able to change this mixed expression into a rational expression. Okay, so again, 4 plus x plus y all over x minus 5 y. Okay, again, we multiply 4 times x minus 5 just like we did 5 and 7. We multiplied 5 and 7 and we added 4. So following the same procedure, we will multiply 4 times x minus 5 and then we will add x plus y. Okay, so that's what we did. We multiplied x minus 5 by 4 and then we added x plus y. Okay, and then we simplify it. You end up with 5x plus y minus 20 all over x minus 5. So your mixed expression now is converted to a rational expression using the rules that we use to change a mixed number to an improper fraction. Okay, and let's use that skill to be able to answer example 1. We want to simplify 7 plus y minus 3 all over y plus 4. Okay, so copy the problem. Okay, and then we multiply 7 by y plus 4 by 7, and then we add y minus 3, and that's what we got. Okay, and then we distribute the 7, end up with 7y plus 28 plus y minus 3. Combine like terms, you end up with 8y plus 25 all over y plus 4, and that's how you simplify this particular mixed expression. Okay, now let's go back to the table tennis ball or the ping pong ball. Okay, let's refer to the beginning of the application the application at the beginning of the lesson. How many table tennis balls would weigh 1 and 1/2 pounds together? And we know that 1 and 1/2 pounds is over 1/10 of an ounce, which is the weight of approximately one tennis ball, meaning we get the weight of one tennis ball and divide 1 and 1/2 pounds, and we convert 1 and 1/2 pounds into a mixed number, which is 3 halves, and then we now have a complex fraction, which we're going to be talking about in example 3. Okay, so from there we know that the main fraction bar indicates division, and therefore this is 3 halves divided by 1 over 10. Okay, and then from there we convert pounds to ounces. Okay, and divide by the common units. So we convert pounds to ounces, which is 16 ounces per pound, and using dimensional analysis we now get this. Okay, so you have ounces and have been cancelled, and pounds unit has been cancelled. So we converted pounds to ounces, and then we find that we now have 24 all over 1 over 10, or 240. So how did we get 24? 3 halves times 16 will give us 24. Okay, because you cross cancel that, that's a 1, and that's a 8. You simply multiply 8 times 3. So if you cross cancel 2 and 16, that's going to be a 1, and that's going to be an 8, and you simply multiply 3 times 8, and that's how you get to 24. Okay, and 24 over 1/10 is the same as 24. Oops, let me not use that. Okay, let me use ink that will not disappear. There you go. So we have now 24 divided by 1 over 10, or 24 multiplied by 10 over 1, or simply 240. So the answer would be, it would take, okay, 240 table tennis balls to weigh 1 1/2 pounds. Okay, so from what we learned so far, let's use that for our next thing that we need to learn. Recall that if a fraction has one or more fractions in the numerator or denominator, it is called a complex fraction. Some complex fractions are shown below. This is an example of a complex fraction. Another example of a complex fraction right there. Another example of a complex fraction. And last one, an example of a complex fraction. And all these fractions, when you're talking about a complex fraction, there's one thing that you need to remember. You need to be able to identify the main fraction bar. So for you to be able to simplify a complex fraction, you need to be able to identify the main fraction bar. Okay? So you can simplify an algebraic complex fraction the same way you simplify a numerical complex fraction. For example, if I have 11 halves all over 15 over 4, 11 halves all over 15 over 4 is the same as 11 halves divided by 15 over 4. And we simply get the reciprocal of 15 over 4 and multiply it by 11 halves. And you cross cancel 2 and 4. And that'll be 1 and 2. So this becomes 22 over 15. Okay? If we use the algebraic version of this, you have a over b all over c over d, and then we do the same thing with the numerical complex fraction. So a over b divided by c over d is the same as a over b times d over c. Okay, and that is the reciprocal of cd, and same way as 15 over 4. Okay, the reciprocal is 4 over 15. Okay, and you get your simplified algebra complex fraction is a times d all over b times c, or simply ad all over bc. Okay, which brings us to simplifying a complex fraction. And when you simplify a complex fraction, you have a over b, same as we have there, all over c over d, where b is not equal to 0, c is not equal to 0, and d is not equal to 0, simply because if these variables are equal to 0, we will have denominator which is equal to 0, which will be undefined. So if you have a over b all over c over d, okay, it is the same as ad all over bc. Okay, and if you notice before, we already talked about this. Okay, if you have a over b, let me just jog your memory here, all over c over d, we simply multiplied those two, and we called it our means and extremes. So you have your means and you have your extremes. Okay, so you multiply those, you have AD, and you multiply B and C, you have your BC. Okay, so let's take a look at example number 3 and see how this works. Example number 3, you want to simplify each rational expression. Okay, so you have 1 plus 4 over A, all over a over 6 plus 2/3. Okay, you want to do is simplify the numerator and denominator separately, and then we simply divide. Okay, so we copy the problem down. Okay, and then we want to simplify the numerator and denominator separately. So this is equal to, just like a mixed number, you multiply 1 times a and you add 4. So 1 times a and you add 4. Okay, just like a mixed number. Or you can rewrite this way. Okay, so this is the same as 1 times a all over 4. Sorry, I forgot to add 4. Okay, so that's how you convert this, the numerator that is. Okay, and the denominator, okay, is simply finding the LCD. Okay, so the LCD of the denominator is 6, and now you have a over 6 plus 2/3 times 2 over 2, because the LCD is 6. Okay, so if this is your numerator and this is your denominator, let me expand this for those of you who already forgot. Okay, plus 2/3. Okay, remember we can write this as a over 6 plus 2/3. Your denominator is 6. And you multiply this by 2 over 2 to get to 6. And you don't multiply this by 1 over 1, which means it doesn't change. So this simply becomes a still, and this now becomes 4 over 6. Okay? So if you notice, if I add those two, I'll end up with a plus 4 all over 6. Okay? And this now becomes, our numerator becomes, okay, a plus 4 all over a. Okay? And this is what we got here. You now have a plus 4 all over a and a plus 4 all over 6. Okay, and then we divide because that's a main fraction bar which indicates division. So it's a plus 4 all over a divided by a plus 4 all over 6, and we get the reciprocal of a plus 4 all over 6 and multiply it with a plus 4 all over a. Okay, and we simply cancel out the a plus 4, and we end up with 6 over a. So the simplest form of this complex fraction, okay, is 6 over a. Okay, let's take a look at letter B and see how we simplify this. In letter B, we have m minus 5, m plus 5 all over m plus minus 3 all over m plus 1. Okay, so we want to simplify this, and we copy the problem first and foremost. Again, this is just like this is very similar to a mixed number. So what we want to do is multiply m by m minus 3, and then we subtract m plus 5. Okay, so basically we do this for the numerator, m times m minus 3, and then we subtract m plus 5. Of course, I'm going to put it in parentheses all over our denominator, which is m minus 3. Okay, or you can simply find the LCD of both. The LCD is m minus 3, and this is what the book uses. Okay, on the denominator side, okay, you simply have m plus 1, so we keep it that way. So let's take a look at how this happened now. So the common denominator LCD is m minus 3, and then we multiply the m with m minus 3, just like what we did here. Okay, and we keep m plus 1, so it basically falls the same way. Okay, like what we did here. Okay, so you now have m times m is m squared, m times negative 3 is negative 3m, and then you distribute the negative 1, that's why it becomes negative m minus 5. Okay, and denominator is the same. And then remember, this is your main fraction bar. That's why I keep on telling you to identify your main fraction bar. And that is a division problem. Okay, so to be able to simplify that, we first need to combine our like terms. And now we have m squared minus 4m minus 5 all over m minus 3. Okay, and we factor m squared minus 4m minus 5 using the x method. We end up with, sorry, I forgot to show that, end up with m plus 1 times the quantity m minus 1, which is the factored form of m squared minus 4m plus 5 all over m minus 3. And then we do our division. Okay, so you get m plus 1 times m minus 5 all over m minus 3. Divide that by m plus 1, or then get the reciprocal of m plus 1, which is 1 over m plus 1, and multiply it with this rational expression right here, and you end up with, you can actually cross cancel m plus 1, and that's all you can cross cancel. End up with m minus 5 all over m minus 3, and that is a simplified form, okay, of that particular complex fraction, okay, using rational expressions. Okay, and finally, let's take a look at example number 4. So you notice it gets more complicated as the examples go. So example number 4, we want to simplify a minus 2 plus 3 all over a plus 2 all over a plus 1 minus 10 times a plus 4. Okay, so LCD would be a good way to start. We want to find the LCD of the numerator, which is obviously a plus 2, and we want to find the LCD of our denominator, which is a plus 4. Okay, so we start, copy the problem, and then we find the LCD, which is a plus 2 for the numerator, and denominator is a plus 4. So if the LCD is a plus 2, okay, that means we need to multiply a by a plus 2, sorry, we need to multiply a minus 2 by a plus 2, the whole term right there, and then we need to add 3. Okay, remember, this is still the same. If for example I have 3 and 1/2, what I do is I add 3 and 1/2, 3 plus 1/2, and then when we want to convert this into an improper fraction, what do? I simply multiply 3 times 2 plus 1, and I keep the 2 as my denominator. This becomes now 7/2, and that's the same thing here. Okay, so I multiply a minus 2 by the denominator, and I add 3 and keep the denominator the same. And that goes the same with the denominator. I multiply a plus 1 with a plus 4, and I subtract 10 this time, because instead of adding, okay, we are subtracting. So this is adding and this is subtracting. Okay, and then we simplify it further by using the FOIL method. You now have a squared minus 4 plus 3 all over a plus 2, and a squared plus 5a plus 4 minus 10 all over a plus 4. Combine like terms. Okay, combine like terms. We now have a squared plus 5a minus 6, and if you notice, okay, a squared minus 4 plus 3 is the same as a squared minus 1 by combining like terms. Okay, and then we simplify by, again, dividing. Okay, or before that, we'll see if we can factor a squared plus 5a plus 4. A squared plus 5a plus 4 is actually a prime polynomial, so we can't factor that. Okay, and now we simply divide. Okay, a squared plus 5a plus 4. Oh yes, it's factorable. I'm sorry. So it is a squared plus 5a plus 4. Yeah, it's factorable. So if we factor a squared plus 5a plus 4, okay, we end up with a plus 6 and a minus 1 using the x method. And a squared minus 1, we know that for a fact as a difference of squares. Okay, and from there we use division. We divide this particular rational, sorry, we divide that, yeah, I'm right. We divide this rational expression with this rational expression. So, and then when we're dividing it with this rational expression, we're actually getting the reciprocal of this rational expression. Remember, we talked about this, means and extremes. You multiply these two, okay, and you multiply these two to be able to solve this complex fraction, which is exactly what we have here. A1 plus A minus 1 times, okay, A plus 4 right there, and A plus 6 times A minus 6 times A plus 2 right there, okay? So when we do that, we simply cross cancel the common factors, which is A minus 1, okay? And from there, we get A squared plus 5A plus 4, A squared plus 8A plus 12. How did we get that? We got the FOIL method by multiplying A plus 1 times A plus 4, which is A squared plus 5A plus 4. And we multiplied A plus 2 times A plus 6, which gives us A squared plus 8A plus 12. Okay? And the secret word for this particular lesson is Barkley. The secret word is Barkley. Thank you for watching.